Hello there. Thank you for posting your question in the Wyzant forums. And my name is Landon. I'm here to hopefully uh, show you down the right path here. So, real quick, I just want to kind of give an overview of how this problem is set up. So here you can see I have a rough diagram of the refrigerator setup. I have it to where the refrigerator is horizontal. Just kind of changing my perspective a bit, just make it a little bit easier. The big equation we need for this problem is our static friction equation. We are given the weight of the magnet and the force necessary to push it down and the force necessary to push it up. So these are all the forces here: force to push down, force to push it up. The frictional force, which could either be up or down depending on which direction we're pushing. The weight, and of course the force of the magnet onto the refrigerator. So the first thing we do here is we go ahead and just solve for our upwards uh, static friction here, just kind of get it out of the way and to work on the problem that you started off with first. So in your problem solving process, you did just about everything right except for when it came to working with the angle theta here. You went ahead and you treated your downwards force as your hypotenuse. But as we can see here, our F1 here is smaller than our weight. So we have to treat our weight as our hypotenuse and our F1 as, well, one of our legs. So pretty much right, just flip it. Flipping it, we go ahead and we get a 53.13 degrees as our angle there. With that, we can find our x and y component for our downward force. And we can solve for our static friction, which ends up being about 0.136 newtons. And as a side note, we're not going to solve for the normal force right now because we can't. We don't know our magnetic force, but we're going to keep that in our mind for the ending here. The second part of solving this problem is solving for the downward static friction, or whenever we're pushing up. So in that case here, kind of keeping the same process here, we're going to go ahead and find our angle first. Now, the big thing about finding our angle is, even though we're all the way over here, we can go ahead and use the relationship of our weight with our upwards force here to go ahead and get our angle. Since vectors are kind of movable and stuff like that, and we can kind of rearrange how they are, we can go ahead and just move this, well, upwards force here to the head of our weight. Done. Good to go, right? So in that case there, we end up getting an angle of 66.42 degrees. Solving for our x and y components for our upwards force, we get 0.1 newtons along the x-axis and 0.23 newtons along the y-axis. So in that case there, our static friction is going to end up being 0 newtons. So physically, that would be the point to where you're pushing up with enough force to where now uh, you're really not getting any frictional force coming back at you. It's kind of a thing there. So with that, we can go ahead and solve for our normal force in this case here. Solving for our normal force, which is going to be equal to 0, we end up finding out that our y component is equal to our magnetic force. So our magnetic force is equal to 0.23 newtons. So putting this together with our previous information, we know that our normal force is going to equal the force of our magnet subtracted by the force of our y component along the y-axis all the way back here. And we're going to be solving, we're going to finish solving, we're going to use this information we got from this problem here to find our coefficient of static friction to help us figure out the final bits of the problem. So with that, we're able to figure out our normal force for that first problem there to be about 0.182 newtons. So going ahead and rearranging this equation a bit, we find that our static friction divided by our normal force is going to be less than or equal to our, well, our coefficient, which ends up being about 0.75. So while the magnet is completely still, our normal force is going to be our magnetic force, right? So in that case there, our static friction is going to be about less than or equal to 0.173 newtons. I hope this has helped, and if you have any problems or questions, feel free to respond. Thanks so much, and have a good day.